Here we go with our video 2 for Algebra 2 Honors, Unit 3, Lesson number 2. And here we're looking at systems of nonlinear equations using these nonlinear systems to solve word problems. All right, so let's go ahead and hop right into this. So we've got our sneakerhead Carlos. We've got his weekly revenue. All right, we want to take note of that it's revenue weekly, and he's thinking about hiring a distributor, and that will cost him this amount weekly. And we want to use system of equations. So what do we want to know? The values for the price P for which the product will remain profitable if they hire the distributor. And the second thing we want to see is what is the value that will maximize the profit if we have a distributor. So first of all, let's start off with some basic business here and understand that revenue minus cost equals profit. So revenue is just what he's bringing in, but then he's got to subtract that cost. And once you take away the cost from the revenue, that's where we get our profit. So let's look at setting this up here also. Oh, it's way off. Now I want something straighter than that. There. So we have revenue on our vertical axis, which is a function there of our P, our price, on our horizontal axis. And so let's go ahead and look at, we got revenue minus cost equals our profit, and we're looking at making a profit, so we've got to do our revenue, negative P squared plus 30P minus the cost, which is 4P plus 25, and that will equal our profit. We want to say Y equals that. Just call it Y. So now that gives us, so Y is going to equal negative P squared plus 30P minus 4P minus 25. We're distributing that negative 1, giving us negative P squared plus 26P minus 25. Now, we want to be profitable. So profitable means this Y, all right, has to be greater than 0. So setting this equal to 0, and let's go ahead and set that equal to 0 right there. And now let's multiply through by a negative 1. So we start off with a positive P squared minus 26P plus 25. Now, our function is this part right here. So it's still, when we put these two together and model them as one function, we're going to get something that looks like that. All right, we're going to get our parabola. And actually, that, okay. So modeling them together as one, we're going to get our parabola like that. All right, and that equals 0. And we look at this and we want to see, can we factor this? Yes, we can. That factors out to P minus 1 and P minus 25 equals 0. So P minus 1 equals 0. If our price is 1, we're profitable. P minus 25 equals 0. And if our price is 25. So what we're looking at is that we've got 1, it's a little off right there. We've got 1 and we've got 25. So if the price is less than 1, we're below 0, we're losing money. We're not making a profit. If it's greater than 25, because of that distributor cost, we're losing money. So for part A, we have a profit, and I'm going to write it this way. We have a profit if 1 is less than or equal to the price, less than or equal to 25. So we can write it like that. If our price is from 1 to 25 inclusive, we make a profit. Now, maximizing our profit. What will maximize the profit? The vertex. Where is our vertex? Well, now we're looking at our negative B divided by 2A. Actually, we don't have to do that. We know our maximum is going to be midway in between our two x-intercepts. So from 1 to 25 is a difference of 24. Half of 24 is 12. So our maximum is going to be 12 away from each one of our x-intercepts, or in this case, p-intercepts. And so we have, for part B, we have max profit if not, now I'm going to put it this way. We have a maximum profit when P equals 13. And we're not given units here. So we can't automatically say P equals $13. That makes sense. But since we're not given the units, we just want to say max profit when our P equals 13. All right, now we have a rocket being launched. It's being launched from the ground, okay? That is important. So our rocket is launched from the ground. We have Y and we have X. So we can just go ahead and assume X is just distance. We're not doing it as a function of time. So it's launched from the ground. And by virtue of this, our y-intercept is 0 because it's launched from the ground. And at the same time, a flare is launched from a height of 10 feet. So I want to show that this way. And now this equation just models what would happen with this. All right, so now we want to see, will they hit one another? And if they do hit one another, at what height? So we're trying to see, will they have the same height? All right, will they hit means will they be at the same height? And this is a simplified problem because we will be looking at the same height at the same time. But anyway, let's go with it. So we're looking to see, does negative x squared plus 10x, will that equal negative x plus 10? Is it possible for negative x squared plus 10x to equal negative x plus 10? So let's add x on each side and subtract 10 on each side to give us negative x squared plus 11x minus 10 equaling 0. And again, I don't want that leading negative, so I'm going to multiply everything by -1 to give me x squared minus 11x plus 10 equaling 0. And once again, I first of all want to look and see, can I factor this? And yes, I can. This factors out to x minus 1 and x minus 10. So x equaling 1 and x equaling 10. So yes, they will hit, because when we model both of these together as one quadratic, we get these two different answers. Now, let's see, at what height? So the first part, yes, they will hit. And at what height will they hit? Well, they will hit when x equals 1 and when x equals 10. So we're looking at, they will hit at y equals, I'm going to use the easiest equation, negative 1 plus 10. So they will hit when y equals 9. So they will hit at a height of 9 feet. Again, going back to our complete sentences, they will hit at a height of 9 feet, and y equals negative of 10 plus 10 and equals 0. Now, I want to ignore the second one. It's not a superfluous, not necessarily superfluous, as we looked at in our first video, but let's just think about the situation. Now, this is for the sake of doing a math problem. For the situation, if we have a rocket being launched and a flare at the same time, if they hit right here, that is going to change the trajectory of both of them, and they will not hit again. So I just wanted to point that out, but I'm not going to make too much of a big deal because, again, we're also talking about what are they launched at the same time. We're looking at three-dimensional space, but all right. So yes, going off of what we have here, they hit at a height of 9 feet. And one other thing I want to point out there, that means they hit 1 foot away from where they were launched and at 9 feet high. That's the other part. All right. Number 3, we have a daredevil jumping from the CN tower. We have height in meters now. All right. Height is in meters. He's jumping, and looking at this here, we're 360 meters up. So when he jumps, all right, we'll put 0 in for t. So we're looking at h as a function of time. And he's jumping from 360 meters up. And he's following a parabolic path. And at some point, he opens his parachute and he follows a linear path. And now we want to know how long after jumping did he release his parachute. How are we going to interpret that? Well, we kind of got to backtrack on this one right here, and we're just looking at negative 4.9 t squared plus t plus 360. When does that equal negative 4t plus 142? Because we're looking at a function of time. So we know they're going to be equal because of what we got in our situation. We start off with parabolic. He does open his parachute and then start to sail down. All right, so now we know what to do here. We're going to add 4t and subtract 142. Subtract 142. Giving us negative 4.9 t squared plus 5t plus 218 equaling 0. Not a very good 0. There we go. That's a better 0. Now, so that gives us, we'll go ahead and put, we've got negative 5 plus or minus the square root of b squared, and I'm just going to go ahead and say, we know 5 squared is 25, minus 4 times negative 4.9 times 218. And that is all divided by, we'll go ahead and say negative 9.8, 2 times negative 4.9. Now, let's look at this here. That's not the one I wanted to look at. Okay, this is the one I want to look at. So now I want to go ahead and let's look at, and we'll put this in parentheses, negative 5, no, we won't do it that way. Let's just look at the square root of 25 minus 4 times negative 4.9 times 218. And we get 65.56. So let's just put that down, 65.56. There we go. There we go. So now we want to put, that is approximately negative 5 plus or minus 65.56 divided by negative 9.8. All right, so once again, if we, now we're looking at a modeled, we won't do it that way, a modeled quadratic. So if we do negative 5 plus 65.56, that's going to give us a positive divided by this negative, which is going to give us a negative time. All right, because keep in mind, we're looking at as a function of time, so a negative time does not make sense. There's no such thing as negative time, and that's why I guess I should put that in here. T equals that. So we've got T is going to equal, or now we can say T is going to be approximately, and now we have negative 5 minus 65.56 divided by negative 9.8. And again, because we have all negatives here, go approximately, we can do this as going back to the, now we keep that number and we can say just plus 5 and then do that divided by a positive 9.8. And we get approximately 7.2 seconds. Now, I've seen some places where seconds is abbreviated S and sometimes SEC. But so 7.2 seconds. And again, back to our complete sentence answer, the Daredevil released his parachute 7.2 seconds after jumping. Approximately 7.2 seconds after jumping, he released his parachute. And real quickly, I just want to throw in here, when we look at modeling them as this one quadratic right here, we get something, let me see, this was 360, and we have plus 218 would be our y-intercept for that one. So we can say it models something like that. And again, that negative t back here, again, that doesn't make sense to have a negative time. We can't have a negative time. So we're looking at 7.2 seconds is when he released his parachute. So I don't want you to get mixed up with looking at, this is the modeled quadratic of combining these two. So it's a little different than this. This is the actual right here where he jumps following this parabolic motion. He opens his parachute. So according to that one, our 7.2 would actually be right here for that one. But the yellow models these two combined. Just want to point out that detail there. Okay, now for our last one, we have a punter kicking a football, and we have its height in meters and seconds. So again, we're looking at height as a function of time. And he's going according to 0.8. So we're in meters, 0.8 meters above the ground. So he's kicking it right about, what's that? Just under 3 feet off the ground. So his quadratic of kicking the ball is modeled by that. And then we have this guy rushing in from the opposing team. He's trying to block it, and it's modeled by that equation right there. And will the blocker knock the punt down? So we're saying if he's going to knock it down, then they've got to be at the same height at the same time. And again, we're just setting these equal and not going into the details of this. So we have negative 4.9 t squared plus 1824t plus 0.8 equaling negative 143 t plus 4.26. And you know what to do now. We're going to have to add 1.43 t. That made it worse. And subtract 4.26. So adding 1.43 t and subtracting 4.26. Very straight there. So that gives us negative 4.9 t squared plus 1967 t minus 3.46 equaling 0. And now we've got 19 negative b, so negative 1967 plus or minus, and we've got b squared 1967. Oops, put my decimal in the wrong place there. 1967 squared minus 4, negative 4.9, which is 19.6. That was negative 3.46. All right, I don't want to get too sloppy here. And that is all divided by, again, 2a is negative 9.8. Now, I'm going to show approximate. I'm not going to bring the calculator back up, but I'm going to show the approximations from the calculator, but rest assured that in the calculator, I did not round off my answers until the very end. So this gives us negative 19.67 plus or minus 1783 divided by negative 9.8. And here I'm going to go ahead and put my approximate because we're approximating now. And now what this comes out to, well, let's see, we have negative 1967 plus 1783 divided by negative 9.8. And we have negative 1967 minus 1783 divided by negative 9.8. And we're creating a little different situation here because now both of these are negative numbers divided by negative. So both of these come out to be positive, and this comes out to 0.18 seconds, and this one's approximately 3.83 seconds. How do we know which one is correct? Well, again, let's think about the situation. Here's, well, if we model them together, that quadratic looks a little something like that. All right, we have a negative 3.46, so our y-intercept is below the axis, and we're saying (0.18) and at 3.83. Well, think about it. We have the punter kicking the ball. The blocker comes in. If he hits the ball at 0.18 seconds, he's not going to hit the ball again at 3.83 seconds. So again, we have an answer that doesn't make sense. It's mathematically correct, but does not make sense in the situation. So yes, he can block the punt, and that will happen at 0.18 seconds. All right, and that's it for our video.